Hello my dear students, welcome to your Geography's online class. Today in this class we will be discussing about the different theories related to the origin of the earth. The first of the theory to be discussed is the gaseous mass hypothesis of Kant. The theory was postulated by Professor Immanuel Kant, a German scholar, in the year 1755. According to Professor Kant, there existed two primordial matters in our space. And these primordial matters, they were a moving object. And with the movement, they attracted each other due to gravitational pull. On being attracted to each other, they started coming close, which resulted in their collision and thereby increasing the temperature and producing the angular velocity. This angular velocity now resulted in the occurrence of rotation as a movement on these matters, the primordial matters. With the increase in this rotational speed, the centrifugal force of the primordial matter also increased. Now, on the collision, as the temperature had already increased, that had resulted in the matter to turn into a gaseous object. That is, the primordial matter, due to the increase in temperature, had converted into a gaseous matter. Now, this gaseous object, for which now is witnessing a change in its rotational speed, caused the gaseous matter to eject out of the primordial matter. Now the ejected part of these gaseous matter were almost in a ring-like structure. So this very ring-like structure later on cooling, as because it was already parted out of the parent primordial matter. So the ring-like structure later started cooling, and these very rings resulted in the formation of planets. So this is the basic theory about the origin of the earth, as of now to be the gaseous mass hypothesis of Kant. The theory was put forth, the theory of gaseous mass hypothesis could not fulfill the entire criteria, or it did not explain all the bases. It had to face several criticisms, as though it was the first such theory related to the origin of the earth. Hence, despite the criticism it faced, it cannot be denied that it held a very important place as in the discussions of the origin of the planet. The next of the theory to be discussed related to the origin of the planet is the Nebular Hypothesis of Laplace. In a very much similar like situation as that of the gaseous mass hypothesis of Kant, Laplace, who was a French mathematician, postulated a theory called the Nebular Hypothesis in 1796. According to Laplace, the primordial matter already existed in the space, which now was a hot and gaseous object, as opposed to that of Kant, who had explained it as a cold matter, only the temperature increasing later with collision. Here, with Nebular Hypothesis, Laplace has placed that the primordial matter which existed in the space was already a high temperature and gaseous matter. So this hot and gaseous object, the primordial object, is termed as nebula by Laplace. Henceforth, his hypothesis known as Nebular Hypothesis. Now this gaseous matter, as time passed by, cooled down and the volume decreased. With a decrease in volume, it is stated that the rotational speed of the matter increased. So this increase in the rotational speed also resulted in the increase of centrifugal force, now thereby letting this nebula or the gaseous object in the nebula to eject out, or you can say to break out of nebula into a ring-like structure, and then this very ring-like structure that came out of the nebula formed the planets, and the remaining part of the nebula formed to be the present Sun. Now, as per the discussion of Kant and Laplace about the origin of the Earth, they both face criticism on several grounds. The first of to be speaking is that neither Kant nor Laplace discussed about the source of the primordial matter, like where it came from, how did it exist. So these all were not discussed. And even the temperature condition of the primordial matter were not very much clear by the discussions of gaseous hypothesis and nebular hypothesis. On top of that, the planets, those were formed out of the nebula or the gaseous mass of the primordial matter, was not discussed in specific numbers. So as to say, in today's time we have 8 planets, but these two gases and these two hypotheses does not clarify the number of planets that were formed. So these were certain criticism that the hypothesis had to face. But despite the criticism faced, like I said, we consider it equally important as because they laid the foundation for the discussions of the origin of the planet. The third theory to be discussed today is the planetesimal hypothesis of Chamberlain and Moulton. These were two persons, T.C. Chamberlain and F.R. Moulton, who together propounded this theory known as planetesimal hypothesis in 1904. According to Chamberlain and Moulton, there existed a proto-sun. It is the name given to the sun in those times. At present, we call proto-sun as the sun. But this was the name given to them by, this was the name in fact given to the sun by Chamberlain and Moulton, proto-sun. And apart from proto-sun, there existed a star which is much more bigger than the proto-sun. Now, this bigger star happens to approach towards the sun, that is the proto-sun. And as it comes closer to the proto-sun, as because it is bigger and has larger gravitational force, it resulted in attracting the proto-sun towards it. Now, not entire part of proto-sun did go on to collide or go on to attach with the bigger sun or the bigger star, to what is we call companion star. So, a matter of the gaseous matter of the proto-sun started ejecting out of it. As even in the present, this theory was based as of we see even in the present time with the sun ejecting out some of the other matter. So in a very similar manner, because of the attraction caused by the companion star towards the proto-sun, the gaseous amount, a certain amount of it, started coming out of the proto-sun. And this very ejected matter, which came out of the proto-sun, was termed as planetesimal by Chamberlain and Moulton. And hence, the theory been named as planetesimal hypothesis. So this ejected matter that came out of the proto-sun were of various size. They were not of the same size, or there was no such evenness in the size. So in this case, the larger objects or the larger matter that got ejected later formed the planets as they attracted the other smaller particles that were scattered in the space. And these larger objects or the larger planetesimal resulted in the formation of planets. The fourth theory to be discussed today is Tidal or collision hypothesis of Jeans and Jeffreys. This theory was propounded by Sir James Jeans in 1919. But with the same theory, a slight modification was been provided by Harold Jeffreys in 1929. As per the theory, there existed two heavenly objects. One was the sun, which is a gaseous matter, and the other was a star which was much bigger than the sun. So according to the theory as discussed by Sir James Jeans and Harold Jeffreys, that the bigger star accidentally happened to come closer to the sun. And as it came closer to the sun, a cigar-shaped gaseous portion of the sun started ejecting out of the sun. And this all happened because of the gravitational attraction caused by this star, the bigger star that happened to pass by the sun. So as this cigar-shaped gaseous matter ejected out of the sun, it did not again return back to the sun, rather followed the companion star or the bigger star, as because the star had much more gravitational power to pull off than as compared to the sun. Now these very ejected matter later broke out into smaller particles as cold objects, which are known as planetesimals, and these very small portion of that elongated cigar-shaped gaseous matter that got ejected out of the sun later start forming the planets on cooling down. So on this basis, as because it's a force that is exerted by the star passing by the sun, a tidal force due to the gravitational power, hence the theory is being termed as tidal hypothesis. So this is for the day class. Thank you.